Hello all. In this video, we are going to continue on the Bangalore house price data analysis using R. So in this particular video, whatever we have done along with that, we will do few more models and try to understand some of the way we split the data set is actually called random stratified sampling strategy, and we will try to understand what is it doing. So here let me first talk about the strategy of splitting the data by location. So here you remember that we call the locations unique locations and put them in location names. Then we just created a space holder for train and test, set the set, and then for each location we created a sub data set here, and then we took the n1 and we put it in the ceiling, and then we draw the sample, and in that sample we just put it in the idx and then test, and then we just append that in the test. So that for each location we created a sub data set, and then for each location whatever the sample we have, we just split it into two and into 30-70 way into train and test data set. Now this strategy is known as random stratified sampling strategy. The idea is, imagine you want to draw sample all over the India. You can either draw simple random sample with replacement. In that case, what might happen that you made quite a few samples from big states like Maharashtra, Tamil Nadu, or Uttar Pradesh, but there are some small state like Sikkim, Goa. Okay, in those states you may not find even a single sample. In this is not a very good strategy, because you want representative of from each sample. Similarly, here for each location I want a representation. So that is exactly what we are doing. This strategy is called random stratified sampling strategy, and because of that we avoid the issue of inconsistent modeling. Now our model is consistent across all locations. So you can apply this strategy when you will handle state level data or any location or any data which will have some kind of categorical variable or too many categorical variable with quite a few locations. It is good to stratify the samples using or draw the samples using stratified sampling strategy. So that is why we avoided all those problems and we able to move on to new models. So let us try to fit a new model. So new model. So this was our best model. So for the third model was the best model, and can we add few more thing in the best model? So mod 4, and maybe what we will do, we will just update because we don't want to again run the model 3, so we will just mod 3, we'll just take that, and whatever we have along with this, maybe we put a square term of this, a square term of that, plus log of bath square plus I log of BHK square. So if I just run this, it takes a little time. Yeah, it's done. So I just put a summary of mod 4 model, fourth model. Okay, it is similar to 83%, not much. Let me just little bit increase the place. We can just a bit more space. Yeah, you can see Ashok Nagar, Ambedkar Colony, AGB layout. Okay, these are like abstract layout. Okay, 8th block Jnagar. As anyway, we will see what we have here. Nagar is third stage. So what we are seeing here, okay, there is some issue. It has square terms, but we are not seeing the square terms. Okay, maybe they have added the square terms at the end, so but they are not printing it here. So what we will do instead of that, we will just say coefficients mod 4. If we just, okay, it is just coef maybe I will just say tail of this table. Yeah, so you can see at the end it's added these parameters. So you can see that the t value for log total square feet square is very high, log bath square is also very high, and log BHK square does not have much effect, t value is very small. So square quadratic effect for bath in log scale and total square feet in log scale does have a quite significant effect, looks like. And then what we can do is you can keep adding more and more samples, more and more things. So maybe you can try one more. Total square feet cube. I just okay, 4, and then if we just see this, yeah, both square and cube does have effect, looks like. Bath square, does have an effect. So what about bath cube and BHK cube? Let us run this. Okay, so if I just add the end, so BHK square and BHK cube both are now effective. Bath square and bath cube is also effective, and square and square feet cube are also effective. So we can keep doing it, but let's see if we, by doing this, by adding these predictors, engineered predictors, if we really adding any value or not. So let us try model these tests. Okay, all right, and then this is TF test, this is price hat, and looks like it's doing fine. Yeah, we will see, and then let us write price RMSE 4 out, this is 4 hat 4, and 69, whereas RMSE 3 out was 75. So adding these numbers, adding these features actually helped a bit. So you can see feature engineering is helping. These are out of the sample. Remember that these are out of the sample RMSE, root mean square error. So probably this is a good thing to have. And 4, let me take my 4 and 0.679, whereas my this is 6.2, this is even pushed further 70%. So model 4 is so far best, right? So I can just put it there, R2 R square 1, these are obviously outsample R square 2 3, and this is 4, right? And so let's see, three, 1 1 2 2. So clearly RMSE has dropped over, and fourth model is much better, and out of the sample fourth model is this. And then r square 4 equal to r square 4 r square 3 equal to r square 3 r square 2 equal to r square 2 r square 1 equal to r square 1, right? Out sample r square, out sample r square is this. So it has gone up to almost 70%, 67.68%, 67.9 is the maximum out of the sample r square that we can found. So what now we can try, we can also try to implement tree regression. Okay, so tree regression is the way we can do that. Library r part, okay, r part, okay, and then model 4 dot formula so what we can do is essentially I can just fit r part and then if I just run it, so this is the formula, right? So why not go to df train, and this is mod 3 or no, mod 5. We hope this will be okay. This has given me something, and then all right, quite complicated. Let us not try to, let us use it as a black box. First is we have to predict model 5 as a black box. Let's see how it is doing. Okay, looks like it's doing okay. And then RMSE 5 and RMSE square. RMSE 5 out, this and this, 88, and RMSE 5 is this. Alright, so So this is somewhat not doing so well, the regression tree. Or what you can do, you know what, you just drop these. If you just drop these engineered feature, and let's see what it does in the RMSE out is similar, not much. So whether you put the engineer feature or not, tree regression tree is doing slightly worse than, I would say, the RMSE out is out comma C5 out. So now, so we can see that it is doing somewhere between third model and the second model, and R square 5 is doing out sample R square equal to C out sample out square 5 equal to R square 5. So out of the sample R square is also here, also it is doing somewhere in between second model and third model. So far the fourth model is the best model that we have find. Now since fourth model is the best model, what we will do, we will try to do some residual analysis of the fourth model. Okay, residual analysis of the fourth or the best model. So you can, if you want to take a break, you can pause the video, you can take a break and come back and see it, because now we are going to turn a bit. Okay, all right, I hope you have taken your break, and let us try to do the residual analysis of fourth model of the best model, and we hope that our fourth model has done reasonable job in terms of the fitting the, now here is the residuals. So let me just take it as E. Okay, now first thing probably what we will do, I will just put hist equal to E. Let us see how the histogram looks like. Looks like it's normal in class equal to 10. If I just do that, I don't know. All right. Probability equals to true, and then what we do is we can try to do QQ norm as E, and then CH equal to 20, color equal to say magenta. Okay, that's not very good. So that means definitely the QQ line LWD equal to 22. So that means this error is heavy tail distribution. Error has definitely a heavy tail distribution, though it is behaved like a bell shaped, it has doing reasonably bell shaped, but it's definitely has a heavy tail distribution on both sides. Okay, on both sides there is some quite a bit of underestimation and overestimations are happening. So in this case, I mean, effectively, if your prediction is doing well, probably you don't want to be, it should be fine. But at the same time, if it is a heavy tail, that means you should be aware that there are cases where it is either doing heavy underestimation or heavy overestimation. So that means these are the points where is probably happened heavy overestimations, and these are the places where heavy underestimations have happened, right? So in this case, what can we do? I mean, you have to be, if you take it as with a pinch of salt, then you say that okay, I am fine with this, right? And or you try to put more features and you try to figure out if you can tame this underestimation or overestimations. So one way to put this underestimation and overestimation under control is put more and more new features which probably affect the price. You brought those into the in your analysis, just not location and bathrooms and how many bhks and all the only and total square feet area types. These are the only 5 variables effectively we have used, but other than that you should use other variables also if you have available. Now for example, ready to move, you can try to add those variables as well. So now if you want to still do the analysis, say whether if you are interested in doing inference, statistical inference, so statistical inference will probably in this analysis will be valid. You can ask me why. Because the sample size, even in the training sample you have 9,000 samples, whereas your dimension of your x is so maybe x test, wait a minute, so what you can do is, sorry, no, what I have to do, probably I'll tell you exactly what will be the model. So model 4, mod 4, model dot extract, model dot extract, model 4 x and so model extract and mod 4, that's it, model. Okay, or one way of doing it is simply mod $4 model. If you do that, and so first and then is equal to x comma -1, so the number of actually dimension of x, just on it, so 12. So you have 9,827 training samples that you are using, that model 4 have used, and there are only 12 parameters. But if you put all the locations, okay, that is where you need the locations, fine. All right. So model dot matrix mod for, I think if you just say x, and now if you just say that we have intercept, block square feet, area type, and then you are getting all the locations and dummy variables, and then if you put dimension of x, then what you will get is, okay, 9827 samples and 1311 columns you are fitting. It's a dimension, so it's just to an extent a bit of a high dimension, I would say, but not bad. So you have about, for each parameter you have about 10 samples, so not bad. I would not say not bad. So probably central limit theorem will kick in and you will be able to do the analysis reasonably okay. I don't think you will be facing much of a trouble in this case. So the testing of hypothesis for the coefficients are not valid. This argument probably will not be, I mean, is okay, not be correct, but you can probably say reasonably that central limit theorem probably will kick in, and your testing of hypothesis based on these coefficient of t value and should be fine. But you have to be careful that there are certain cases where you are doing quite a bit of underestimation and overestimations. So one thing one should do, that you should do Bruch-Pagan test, BP test, right? BP test. Okay, now I think this will come under library. If I'm not making a mistake, I think it is under library LM test. I think BP test. Yes, Bruch-Pagan test, LM test, correct. Okay, so maybe what I will just do that, I'll just make mod 4. So it takes time generally. Okay, so even Bruch-Pagan test is rejecting, so that means there is quite a bit of heterogeneity is there. So let us try to see how the heterogeneities are there. Let me see the location, the coefficients. What we can do is very simple, is let us take few places like say Rajaji Nagar or something, right? So let us take this kind of places and we can try to take a df sub, create a sub value, and let us try to understand. So this, in these area, these are the values that we have, and for these values df subs, what we will have is we can plot the df sub dollar square feet comma df sub dollar price equal 20 and color equal to magenta. So this is pretty much the data that we have, and then if we this is the data that we have. So this is the total square feet and this is the data. And now if we do a df sub, in the df sub dollar price hat equal to exp, what we can do is mod 4. Let us take mod 4 and new predictor, which we have to first predict mod 4 comma new data equal to df sub just for Rajajinagar. We are doing the prediction for Rajajinagar in this case. Okay, so let us see df sub. So now I have a price, predicted price for these values. So most of the places I have values. There are few cases where I don't have values like NA. So I have NAs here, so which I can't do much. And then what I can do is essentially points I can plot is essentially this comma df price hat is color equal to black. Alright, let us try to build that PCH 20. So this is where we are doing, and these are the points. This model missing these points, you can see for the large points this point is underestimating, clearly underestimating. Okay, and that is why we are seeing for different, here it is trying to do very good because you have all the values and all these things, but here clearly it is bit of underestimating. So now similarly, if we just go and take another area, so we did for say other than Rajajinagar, here I think we have the Rajajinagar. All right, let us try to take summary mod 4 and what is this? Okay, Ashoknagar. Let us see how this happens. Okay, now what I'm going to do is very interesting. That is going to be a bit of an interesting thing. I am going to create a data set which is rbind.data.frame with df sub and df sub 1. Now you can tell me what is df sub 1. I don't have any df sub 1, but I'm going to make one. That is df train, and here, and instead of Ashok Nagar, this is where the Ashok Nagar I'm going. So df sub 1 will have right. Okay. Alright. So okay, I will do this. Okay, let me just do this guy. Run it once more, and now it is fine. Now if you look into the df sub, it has first Rajaji Nagar datas and then 2 Ashok Nagar. Okay, that is where the problem probably. Okay, so what I will do is df dollar location table and sort. Wait a minute, SORT descending equal to true. Descending equal to true. First, I don't know why it is not happening. So I want few more data set. Actually, I want a location with a little bit more data set. Summary equal to data mod 4, maybe white filled. All right, so maybe white filled. Okay, so I have first Rajaji Nagar, then I have bunch of white filled. Okay, now what I'm going to do is first plot all the Rajaji Nagar cases. df sub Okay, so I have to put some x label equal to total square feet and y lab equal to price. Okay, otherwise it's taking some here. Sorry about that. All right, and then I'm going to put these points where it is going to be white filled. Okay, So this is a bit of a different issue, or gray. I think I can put a gray, that will be probably a better number. Okay, now if you do the prediction, and first you're going to put the points, bunch of points for, instead of price, the price hat, but instead of gray using black, and okay, and here you have bunch of, it's a red, and instead of this you just see Rajajinagar. Set. So let me just zoom it. So the magenta is the actual numbers, and you can see that reds are the actual the predictions, and then there is quite a bit of underestimations are happening, whereas the model here is doing pretty good in terms of, you can see that it's actually able to pick this, this kind of log linear behavior to an extent, right? It's quite great actually in that sense. And then we can try to put the same thing using maybe another plot I will just create out of it with log linear. Since these are all log linear, I'll try to put it in log linear scale. So log of this and log of price in log scale, total square foot, log scale, log of price. So if I just plot this, so you can see that this is better. And then if you just plot log of this and log of this is also to an extent better. So but I need to, I think quite a few are actually down, so maybe I will just increase the y limit, see from maybe from 2 to 8. I'll just get 2 to 8. You can see systematically the price in the white field is slightly lower than the Rajajinagar. You can, I mean, clearly this is the Rajajinagar. These points are in Rajajinagar, and whereas these points are in the white field. Now white field also, when the size of the house increases, that time in terms of total square feet, the gap, they are kind of overlapping when the size of the flat in terms of total square feet decreases, that time you can see there is a clear-cut premium that you are paying for the Rajajinagar compared to Whitefield. For a larger house, this premium or gap is not that much. The slope is slightly different. Whereas now you do this thing, and then we have to plot this in the log scale. Remember that. So now this is the predicted values of for the Whitefield. These are the predicted values of the Whitefield. So Whitefield does reasonably okay, and if you just do this for the Rajajinagar with red, now if you see that clearly the Rajajinagars are the red points, and for the Rajajinagar the points are bit higher on the side, whereas clearly there on an average it is higher compared to the Whitefield. So it is much more clear when you plot it in the log scale. So, and that means whenever you're doing modeling the housing price, in fact any economic activity which related to price, my strong recommendation is always work with log price, and along the other variable with the log price, the feature of the economic activity also, like square feet, in this case square feet, number of bathroom, number of bedrooms, these are all part of the square feet and features. So take the log transformations. The log transformations works in economics, works amazingly beautiful, because everything in economics sort of works. There is called economies of scale. The economies of scale happens in the exponential scale. So when it becomes so, that is one of the reason, if you can afford, you should. If somebody is investing, they say that you try to invest in larger apartment, perhaps because your appreciation will be better. People sometimes say that because of the economies of scale. So economies of scale gets captured in the log transformations. So, and we can see that visualization also clearly explain that. So with this I will stop here. I will hope you enjoyed these particular weeks, complete week on the complete hands-on. One way to learn regression and classification using hands-on data analysis only. I would recommend you try other models, try to apply more engineering engineered features, try to do some stepwise variable selections, maybe lasso, ridge regressions, try to check the multicollinearity. I have not done any of those yet. So if you do that on the, so far model 4 looks like the best. Try to apply all those advanced technique that I have taught you, maybe random forest on the top of this. I believe that will give you a very good results. You can improve the accuracy a much better. You can reduce the heaviness of the residual, that is overestimations and underestimation, to a great extent. And I hope you will enjoy this data analysis to a great extent. So I'm going to share this code on NPTEL platform. Please download this code and try to run on your side and check if you are able to reproduce these results, and then try to improve these results using more engineered features, more stepwise selections, and then try to look into the variance inflation factor, maybe reach correction, lasso correction you can try. All these will help you to improve the prediction accuracy of the model. I hope you enjoyed it. Thank you very much. See you in the next week.